Good morning. Okay, so let's crack on. So this is asking you to fill in the blank in order to retrieve all of the pets and their owners, but only, well, if they have an owner. So some of them don't have owners, right? And so it's a left join. For those of you who said inner join, or those of you who said left join and got it right, can anyone explain why it's not inner join? No? Well, I know at least 6 of you have chose left join, so I think 6 of you know the right answer. What happens when you inner join? What don't you get? Morning.
The pets don't have owners.
Yeah, good. The pets that don't have owners, right? And this says to retrieve all the pets and their owners, if they have one. Or multiple owners, yeah, so the pet will be repeated. Yeah, that's fine. Why isn't right join correct? What would that do? All the owners, yeah, even if they don't have a pet. Brilliant. So this week we're going to finish off our SQL. This is the last week of SQL we're going to do. So hopefully this is as complicated as the SQL is going to get on this course. And we're here. We're over halfway, as I was saying earlier. You've had 6 weeks. You've got 5 weeks left. It's nice. So it's called Constraints and Aggregates. It's advanced SQL. And then you've got versioning and testing of Chem, so some more programming. Any questions on the coursework that I could answer here? Or is everyone doing okay? Silence. People are busy with their other coursework. Right, lovely. Okay, so today we're going to be looking at aggregate SQL statements. We're going to be looking at subqueries. And then we're going to be looking at constraints as well. Obviously, these words will make a lot more sense once you get into it. So we're going to get aggregates, subqueries, constraints, got some questions. And then if we have time, I've got a list of interview questions that I've put together based on people I've harassed in industry to give me their interview questions. And I've got a prize for the person who can get the most right. It's a prize I would keep if you don't want it. So it is fairly decent. If we have time, we'll do that anyway. So starting off then, aggregates. So aggregates allow us to group multiple items together when we're retrieving data. So that means instead of retrieving a bunch of rows, we're retrieving like a certain number or something like that. Can anyone think of an aggregate we might have seen? Count, brilliant. Limit, that just limits the number of rows, but count is an aggregate, good. So for example, if we wanted to count the number of pets, select count pet ID from pets. What that does is say, okay, how many pet IDs are there in pets? In this case, 4, I think. Yep, 4. And that's all it returns. So it just returns the number 4. We can do counts slightly more complex with a where clause, so we can say count the number of pets for this owner. How many pets will this return? 2, yeah, brilliant. Okay, we're way ahead of the game here. But what if we want to count the number of pets for each owner? Has anyone who's done SQL before have any potential idea as to what we can do? If I want to count the number of pets for every owner. Yeah.
Get the average number of pets.
Not the average. Close.
Grouping by owner and then...
Good. Yeah, brilliant. So we can use this thing called a group by clause. So we can select owner ID, count the number of pet IDs from pets, and this is the group by owner ID. So this means I'm going to do this for each one of these. Yeah? So the result looks something like this. So we have every owner ID here and the number of pets they have there. So the group by clause says, okay, I want to do any of my aggregates according to whatever column I put in my group by. Almost the same as when you're using the order by as well. Same sort of syntax. We can do this by pet type instead. So if you wanted to select type and the number of pets for each type, you could do the same thing, but group by type. It's exactly the same syntax, just with a different column. But we're not limited to counting. I think you said average a second ago. We can do things like max, min, average, sum. So we can do slightly more complex statements like selecting the owner ID and calculating how much of a deposit they've paid in total across all their pets. So what we do is we say for every owner, I want to add up all of the deposits that they've paid, and we get something that looks like that. We can do multiple aggregates, so you don't have to just stick to one. For example, if you wanted to get the total deposit and the average deposit per owner, you can do this. Owner ID, sum deposit, average deposit, then group by owner ID. Now, there's no reason you have to select owner ID. I just do because it makes the tables nicer. So you actually see which owner has which value. So, for example, we have 1049 who's just got a hamster. Their total and their sum average is the same. So moving on to something more complex, I think aggregates is quite a simple one to get started with. Sometimes you need to use a query to be able to query something, right? So you're either trying to calculate the average of something and then use that average to do something else, or you want to perform some sort of inner join on a subquery. These are called subqueries. Now, one way you could do it is to execute a query, get the results, then build up a new query itself and send that back off to the database. Or you can build one giant complex query, which is what we're going to do here. So I've added some more data just to the table, just to make it a bit more interesting. And let's say we want to get all the pets who have a deposit which is higher than the average deposit overall. So the first step here is we need to calculate the the average deposit. So select average deposit from pets. Yeah? What's this going to do? Yeah, it's just going to return the average of the deposit column. So it's going to give us 95. We can then use this in what's called a subquery. So we have, in this case, we want to select the name of all pets, so select name from pets. Then we have a where clause, where their deposit is greater than, and then our subquery here. So that query I've just put here. So anything that's returned from this query is going to be used in this statement here. And here we're going to get Barney, Ralph, Misty, and Coconut. The top two are my actual dogs. The other two, I have no idea. We can join these subqueries as well, so you're not just limited to using them in a where clause. You can do more complex things. So if we wanted to retrieve the name and deposit of all pets alongside the average deposit for each specific pet type, we can do this as well. So let's break it down. First, we want to get the average deposit for each type of pet. So dog, cat, hamster, that's the only three types we have here. And we can do this. So select type and average deposit. I've used a pseudonym here, and I said I want to call this column TD. So average deposit, this will be known as TD in my query. From pets, and we're going to group by type. So I want the average deposit for every type. That as TD on the end, we've seen, I think, once or twice before, and all that means is I'm essentially selecting type and TD. That's what I've called this. It's just a pseudonym for the column. So that's going to give me this. So every type and the average deposit for that type. We can then join this table to our larger query. So let's break this down a bit. So we want to select the name, deposit, and this will be our type average from pets, but we're going to inner join the pets table to this subquery table here. So this gives us this table. We're going to inner join this table on pets.type equals subquery.type. So we're saying I want to inner join based on these columns. So the resulting table essentially takes this data and appends it onto the end based on what the type is. And then we've got this subquery.td here, which refers to what I've called this column here. Does that as TD make sense? Is anyone confused by the as TD? No, good. Okay, so we've inner joined a subquery onto a main table, and that's really as complex as these things get, is joining tables based on subqueries. You can do some other cool things with subqueries. Oh, there you go. So that's the result of the query. You can insert using a subquery. For example, if you wanted to transfer all cats and dogs into a new table called Big Pets, you could insert into Big Pets and then provide your query. So instead of providing values here, I'm providing a query statement. So any pets where their type is dog or cat, they're going to go into this new big pets table, just like this. And that's it. You can also do updates and deletes. Well, you don't really need to use deletes, but you can use deletes if you want in the where clause. But that's subqueries, and that's as complex as I think we're going to get. Has anyone got any questions on the subqueries? No? So all you're doing is every subquery creates a new table, right? And then you're either joining it or using that data in a different way. Okay, so constraints then. So a constraint limits what can be inserted into tables and columns. We've already seen some constraints. So primary key, that's a constraint. And our foreign key constraint as well. What does the primary key constraint do? Can anyone tell me? Why have I put this here?
Make sure it's present, it's always, it's not null.
It's not null, good, yeah. So that does mean it can't be null. What else does it mean? What's the whole point of a primary key? It's a unique identifier. So anything in this column must be unique for every row. Okay? So that primary key constraint says when you're inserting into class, we cannot have a class ID that already exists, and it can't be null. So that's all it does. Foreign key constraint, kind of similar. This says if you're inserting into this table, and you're telling me that the teacher ID is something which doesn't exist in the teacher table, I'm not going to let you insert that data. I'm going to refuse and say no. Because this teacher ID must exist in the teacher table, otherwise it's not consistent, right? Because you've got a missing teacher. Unless it's null. If it's null, it doesn't exist, so you're fine there. We do also have other constraints. So we have things like unique, index, not null, default. The unique one, every row must be unique, kind of like primary key, but primary key is also an identifier for the specific index. You got index, which is kind of confusing because what it does is it allows the database to index and search rows based on this column. Now we'll see that come up a bit more in 2 weeks' time when we talk about scalability, but indexes can be quite important depending on how you're searching the data in the database. Not null, again, another one which was kind of included in the primary key constraint, basically means it can't be set to null. You can't have an empty value there. And then default is slightly more complex. If you don't insert this value, you get a default value instead. So here we've got 4 columns. If I insert something into class, but I don't put anything for column 4, it'll just be set to -999. Yeah.
Can you add like a double constraint to a column?
Yeah, you can add double constraints. So, for example, you could go column 3 int not null index, or you could go column 3 int not null default, but that wouldn't really make sense because if you're defaulting it to something anyway, it's probably not going to be null. But it's a good shout because the difference between default and not null is that if you had just default -999, I can then update that row to be null. But if it has the not null constraint, I can't update it to be null. And I can't insert it or update it to be null. There are 2 more. So there's an auto increment, which does exactly what it says on the tin. If you assign a value in auto increment, what that means is you don't need to provide that value. It'll automatically increment for every row you insert. So if you add 1 row, you get 1. 2 rows, you get 2, so on and so forth. Then there's check, which is, again, a slightly more complex version of check, in that you can provide a bit like an if statement to ensure that there's some consistency here. So, for example, we've got a table of adults. Well, they're not an adult if they're... We've got to ensure that age is greater than 18. That should be greater than or equal to 18, really. But you get the point. It's checking that age is greater than that, and if it isn't, then it won't let you update or insert that row. Okay? So it's a great way of maintaining consistency in the database. And that's it. Yes?
Is there a way to specify a custom equation to auto increment instead of incrementing by 1? Let's say I want to increment 100, 200, 300. Suppose 100 seconds, 200.
Not easily. There are things in SQL called macros, where you can write sort of a sub-procedure in the database and then reference that sub-procedure. but not naturally, no. You'd have to use some sort of sub-procedure for that. Any other questions on constraints? No? Good, in that case, we're expecting 100% in these next 4 questions. So here we go, we've got our Menti up. Let's get some people in here. So we've got 3. Does it just assign you a flag, or are you actually Swedish? It doesn't know whether you can pick these things or not. 15. All right. Let's get started. So, which of the following constraints can act as a barrier to invalid data? So, what stops invalid data? We got index, check, default, auto increment, and unique. There are multiple right answers. Yep, so check stops you putting in invalid data. Default prevents you from just leaving it empty. And your unique value at the end means everything has to be unique, so it ensures that consistency in the database. Auto increment, I wouldn't really, I guess you're not completely wrong with auto increment because it does ensure that it increments every iteration, but it's not a check itself. You can still override the auto increment if you want, unless you apply a check on it instead. Okay, number 2, so we've got some SQL statements on the right, and I think the question's going to be related to grouping and aggregating them. So which query returns the average age for every type of pet? So we're trying to average the age for every type. Part A, yes, good. So that was a bit of a cheeky one by me there. I put average instead of AVG, but it's just AVG in SQLite. Yeah, A, so pets.type, we're averaging the age, and we're grouping by type, okay? Why isn't this one correct? Why are we not grouping by age? Type of, yeah, the question says type of. Also, that doesn't really make sense, does it? Because if you want for every age to average the ages of that age, doesn't make sense. All right, next one, more SQL. I say more SQL like you don't know this is an SQL lecture. Let's go. Well, apparently someone's answer fast to get more points. That's exciting. Which statement would insert all journeys made in 2023 into the Journeys 2023 table? So subqueries this time. That is a very cruel time limit. I should have upped that time limit a little bit. That was a bit mean. A, okay, good. Yes, so we got the insert into Journeys 2023, and then the subquery, which is extracting any journeys of the year 2023. Someone said B. That doesn't make syntactic sense, does it? If you're trying to insert into, but you're inner joining something. Inner joins only work between data sets or between tables. You can't insert into and then not provide values. So you need to provide those values like they are provided in the top. All right, final one, and then we do have time for some interview questions. I'm going to let you have a read of the SQL first, because I don't know what the time limit is on this. And if it's 15 seconds again, that's a bit cruel. So it's definitely a subquery question again. Got some limits in there. Okay, well, guess what the question might be? Or is that too cruel? Okay, that's 3 people left, so I take that as that's too cruel. Which of the SQL queries will retrieve the 3rd highest salary? Ooh, now that's a split. Okay, what have we got here? So A is correct. C, misconception. What happened here? A and C are identical except for one thing. It's ascending. So you're going to get the third smallest salary for this one. It's a descending because you want it to go from high to low. Oh, I thought you were disagreeing. I was like, oh gosh. Okay, good. B, I mean, that would be a really cheeky way of doing it if SQL would let you do that, but it doesn't. So limit 3-1, that doesn't really make sense, does it?